Okay, so tonight we are going to look at solving a system of equations using elimination, where we have to multiply one or both of the equations first. So previously we looked at solving a system of linear equations where we only had to add or subtract the equations. So now we're going to have to multiply so that the coefficients are additive inverses. So here are the steps to solving a system of equation using elimination. I would like for you to pause the video and copy these 4 steps into your math notebook. We're going to look at this example first. We're going to solve this system of linear equations using elimination. So here, if we look, the coefficients of our x are 2 and 3, and the coefficients of y are 1 and 2. So we could multiply the top equation by -2, so the coefficients of y are additive inverses of each other. So I'm simply going to multiply everything in this top equation by -2, so that I have a new equation where the y terms have additive inverses as their coefficients. -2 times 2 gives us -4x, -2 times y is -2y, and -2 times 23 is going to equal -46. Our second equation we are going to write the same way. 3x plus 2y equals 37. Now when I add these two terms together, we have -x, -2 and 2y cancel, so -x equals -9. We can divide both sides by -1 and get that x equals 9 as our solution. So we now take, just like we did before when we solved using substitution, and we plug the 9 into the first equation. Now I'm going to use the original equation. In case I made a mistake when I multiplied, here I'll be able to find my mistake. So 2 times 9 is 18. Subtract 18 from both sides, and we find that y equals 5. So I have the solution as an ordered pair, 9, 5. And of course, we always want to make sure that we check our work. So I'm going to plug it back into the second equation. So 3 times 9 plus 2 times 5 should equal 37. And 27 plus 10 is 37, so we know we solved the system correctly. So 9, 5 is the solution to this system. So that's our first example. The next example that I'd like to look at, here, okay, for this example, neither the x nor the y can just be multiplied by one number to make it an additive inverse. So I'm going to have to multiply both equations by a number so that my coefficients are additive inverses of each other. It doesn't matter which one we choose. We can eliminate the x's or the y's. So I'm going to choose to eliminate the x's. So I'm going to multiply my top equation by 2, so that I get 6x plus 4y equals 20. And then I'm going to multiply my bottom equation by -3. So I have -6x minus 15y equals -9. Now my x's are additive inverses, so when I add these equations together, the x's are eliminated. -15y plus 4y is -11y, and 20 minus 9 is equal to 11. So divide each side by -11, and we find that y equals -1. Just like we did for the last problem, and just like we have been doing in class, using substitution, our next steps are going to be the same. I substitute the -1 in for y in the original equation. Then I'm going to simplify in order to find my x value. So I get 3x equals 12. And I find that x equals 4. So my ordered pair solution we have is 4, -1. Of course, the very last thing we need to do is to check our work. So I'm going to use the second equation to check it, and I'm going to plug in the ordered pair 4, 1. So I have 2 times 4 plus 5 times -1 should give me 3. 8 plus -5. 8 minus 5 is 3. So 3 equals 3. We've solved this system correctly. So if you have questions or you're unsure, you can go back and re-watch the video to see how we solve these systems. And now I would like you to, in your math notebook, solve this system of linear equations using elimination.